Welcome to online classes. I am Shilpa, lecturer in DCME, working with Dr. B.R. Ambedkar, GMR Polytechnic, Karimnagar. Today we are going to discuss about manipulators. Before going to today's lecture, in previous lecture we discussed iOS class functions and flags. That is, how we can change the format of the output using member functions which are declared in iOS classes, and also the flags we used and we have examined with some example programs. In today's lecture, we are going to learn formatting the output using IO manipulators. Previously we discussed how we can format the output using IO class functions and flags. Now we are going to learn formatting the output using IO manipulators with some example programs. That is, as we know, we can format the output using any of these two features of C++. First one is iOS class functions and flags, and second one is manipulators. As we know how we can perform the modifications using these class functions, now we move to manipulators. In the name itself, manipulates, that means changes. Okay, so in this case, these manipulators are the most common way to control output formatting. This is the most commonly used to control output formatting is manipulators. And manipulators that take parameters are in the iomanip.h include file. That is, whenever we are going to use these manipulators, all those parameters are the function definitions are included in iomanip input output manipulator .h header file. That's why whenever we are going to use these manipulators, we need to include iomanip.h in our program. So what it actually provides? So the manipulators provide capabilities for setting field widths and setting precision and setting and unsetting format flags, and of course fill and inserting a new line and skipping white space in input stream. So these are the that is formats which can be provided by the manipulators. And as we discussed this IO class functions, it seems all these operations are similar to the functions, member functions which we discussed in IO class functions and flags. So try to match these manipulators with those iOS functions. So if you observe here in manipulators, we use set W, set width, like width in width member function in iOS functions or iOS classes, width function in iOS classes, and set precision is similar to precision which we used, and set fill is equivalent to fill, and set iOS flags is equivalent to setf, and reset iOS flags is equivalent to unsetf. We have some idea about all these iOS functions. Now here these manipulators are equivalent to, that means the what is the meaning of width is same as the meaning of set W, and the meaning of set precision is similar to precision. Okay, now we will discuss all these manipulators first. And first one is endl. So write a new line. So whenever we want to print the output in a new line, normally we use slash, and that is, it indicates that the next line to be printed on the monitor should be starting a new line. Starting a new line. For that we use slash n. Of course here double quotes only, that should be string, that is a string, so that should be within double quotes. Okay, so slash n, and that is, this is equivalent function or we use in normal. So equivalent manipulator is NL, NL, end line. Okay, this is equivalent to slash n, and L is equivalent to slash n. So here, in order to get the next output in a new line, we need to use NL. If you are not use this NL, immediately you will get next output, next line output, that is A equals to some 10, B equals to, without any spaces or anything, we will get B equals to 20. So in order to print the next statement, output statement in new line, we use NL like slash n, which we use till now, right? Now, so here, even we can change the basis of a numbers. How we can change? So manipulators are used to change base. Integers normally base of 10, that is decimal. So whenever we are using integers, so that is are of base 10 only. Okay, normal numbers. So if you want to change the base 10 or decimal to hexadecimal or decimal to octal, then these manipulators can be used. Hex, HEX, that is of base 16. If we use OCT, oct, then that is of base 8. So in order to reset, that is, if you change the base of a integer to either hex or oct, and after that if you want to change its base, then you need to use DEC, decimal. That is what it do, it simply resets to base 10. So normally by default all the integers are of base 10. If you want to change the base to a specific one, that is either hexadecimal or octal, then we need to use these manipulators, hex or oct. And after that you need to again reset the base from 16 or 18 to 10 by using DEC, right? Next, set base. New base is 1 of 8, 10 or 16 after decimal or hexadecimal, and base remains same until explicitly changed. So by default that is base 10. If you want to change that to octal, then you change using this manipulator oct. Okay, and until and unless again you reset to decimal, you will get all the integers in oct only. So if you want to change or if you want to print the integers of base 10, then again you need to call this manipulator, that is DEC, until and unless explicitly you change the base, that will not affect on the output. Okay, now so we'll see some example program using this hex, oct and decimal. Okay, and even resetting into previous one, that is 10. Okay, for that here first step you need to remember is you need to include iomanip.h, iomanip.h, and I am taking one number, so I want to print this number in different bases. So for that I am going to read value for the number, so enter a number, Cin number, and in hexadecimal I want to convert this number, so that's why I am using the manipulator hex. Okay, so before that I am printing the string in hexadecimal is number, in hexadecimal is, so I am simply calling the manipulator hex and I am printing that number. So here this hex prints the hexadecimal of this number here. Okay, likewise oct number, again set base to its previous one, so that is 10 number. Right, now let me open Turbo C++ and execute the program. So I was string include I was string.h and hash include new.h. Okay, and need to include manipulate hash include manip.h. Okay, and int main I'm taking one variable int number, and I am using this clear screen, right, and cout enter number c in num. Okay, now I want to print in different bases. So cout num in octal. Okay, so in order to print the number in 8 base, so I need to call the manipulator OCT, and I need to print the number, and L also we use this manipulator, right? We discussed about this and that's why here I am using the tendel. Next, cout number in hexadecimal. So I need to call hex and followed by the number which we want to print in that hexadecimal. Okay, and after that I want to print that into decimal number in decimal is set base set base 10. Okay, and followed by the number and L. Next, let's ch. I think more no need of any more statements. So let's ch return 0. Okay, see any errors? It's fine, I think so. Save the file. Manip base. Run the compile the program. No errors. Run the program. Enter number and 5. 5 in oct is 5. 5 in hexadecimal is 5, and decimal is 5. So better to take some other. 78. If you take 2-digit number, you can able to clearly know. 78 in oct is 116. See here. If you observe 116 in hexadecimal 4e, 4e in decimal 78. That is until and unless you change that base into base into again decimal, you are getting first after executing the first statement, that is 78, by changing the decimal into oct, that is 116. Okay, here in the next line, though we are using the variable num, here the number is changed to base 8. That's why here we are getting, though we are printing num, though we are using num, here we are getting 116 only, not 78, because 78 now changed to base 8. Okay, so 116 in hexadecimal 4e. And again here, though we are printing or we are using the num, here we are getting 4e only, because that num is changed to octal, and octal equivalent is changed to hexadecimal. That's why we are getting 4e. And again, when we use this set base 10, then we are getting its previous, that is that value in decimal, that is 78. Okay, so this is the use of changing the base of a number. Okay, so here, though we use num, that will not print the base 10. Okay, here also, here it will print the value which is in this num, and here we are getting the value which is in this num. Clear? Now width, set w. So it is equivalent to width, specify, that is within parentheses we need to specify the field width. So like that, here if you observe the syntax of this set w, it is also here we need to provide the field width. Okay, what it do, what are the characteristics of this set w? Sets minimum field width on output. So it sets the minimum field width on the output screen, right, and can be used on input or output, and specifies fixed width for only one item. It specifies or it affects only one item, or to only one output statement. Okay, that is to print only one uh, variable. Okay, though we have written some number of output or items in a single output statement, this will not affect all the variables. It affects only one item, and obviously it revert back to the default after printing one item. Okay, and normally when we are using this set table, we try to use this fill method, fill manipulator in this case, because unused uh, positions or characters in set W we want to fill with some other different character. So here fill can be used. Fill characters padding, used when output too small for width, specified width, and large outputs are printed not truncated. Okay, padding. Now, so here this use left and right to justify the data appropriately in the field, and output is right justified by default. So always the output is right justified. And here if you, this is the syntax. Syntax is set w within parenthesis w. It indicates the field width. Okay, so here to print a column of right justified numbers in a 7-column width. Okay, column. So we can use this set w 7 and followed by the variable name, right? So here to print a column of right justified numbers in a 7-column width, we can use this set w7. And this is an example program. So as we are using this set w, we need to include manip. Okay, and cout, initial is star, set w 10. If you remember the previous lecture, we have taken the same example program, but here we call width function, that is not in this particular position. Okay, cout dot width of 10, because that width is a member function, so we need to call that member function using the object, that is cout. Okay, we have observe the same output for the same program using functions. Here we are using manipulator. That's it. Okay. Here only one output. This is not. Will not get this. Only single one. Next manipulator is floating point. Normally here when we are printing a floating point number, by default what may be the values. So unless you use either manipulators, the default format for each floating point number depends on its value. So if you use floating point value, that is if you say the width or the precision, okay, in order before printing a floating point, so all those effects will be effect on this floating point number. Otherwise, if you are not using these cyber manipulators, what may be the format or on which the format of the floating point number depends. Okay, so normally if you are not using these cyber manipulators, then the format of the floating point number depends on its value. Okay, so if the floating point value number is 1.00, then it prints 1. Okay, and here if the floating point value is 1.5000, then it prints 1.5. So that is based on the value it decides how, though that is a floating point number, how that can be printed. Okay, so in this case no decimal point because all the zeros, that's why it takes only this number and no trailing zeros, because here after 5 all zeros only. So it simply trails are truncated, these trailing zeros. And scientific notation for large or small numbers. So here if this is the number, floating point number which we want to print, then it print like this: 1.123456789. Okay, so plus 09, 234576789. Okay, like that. And these are the by default default floating point format. Okay, by default only we are getting these three effects on our value or floating point number. Next manipulator is set precision. So it can specify the number of digits to be displayed after the decimal point. Okay, whatever the number we specify here, so after decimal point we will get that number of digits only. Next, default precision is 6 digits, and precision settings stays in effect until it is reset. Until we reset it, that will be set or effect all the items, not only a single item. And trailing zeros are truncated. As usual, trailing zeros are truncated. Now, what is the format? So, this is the manipulator set precision followed by the number of digits to be displayed after the decimal point, that is D. So, if you observe, this is the example program. Of course, here we need to include the IBM manip. See out, set precision to, and print this value 1234.5678. So as we said this precision, so till 56 only we will get as output 1234.56, because here we set the precision 56, right? Next, set fill. So here it only useful after set W, because using this set W we specify the number of characters for in order to print a particular variable, or we set the field width, and if that value is not occupied, all these characters in the width specified, then we want to fill, we can fill those unused spaces with any special character. So then only we can use this set W, that is it is combined with or jointly comes with set W. Set fill combinedly or jointly come with set W. Okay, and only useful after set W and used to fill the unused positions by any desired character. By default, unused positions of the field are filled with white spaces. By default, we will get white spaces, but if you want to fill the unused fields or unused characters, then you can use this set fill. And fill setting stays in effect till we change it. Okay, now to print a number in a 4 character field with leading zeros. Okay, so then simply here if n is 7, we are setting the width of that 4, width of that number as 4, fill width is 4 and fill with zeros. Then set fill 0. So here only n is 7. So by default it is right justified. So somewhere else we will get 7 with 3 spaces empty before it. So here because the width of the number is 4, 3 unused spaces are white spaces followed by 7. So using this set fill, I am filling those unused spaces with zeros. So 0, 0, 0, 7 we will get as output. So this is also same example which we have executed using class members or member functions. So this is the syntax of set fill. Okay, and set W10 because always the set fill jointly come with set W. Okay, so set initially width is 10 and we are printing only 5250. So the unused spaces or white spaces should be written with star. So this is the output. Okay, now we will use these 3 manipulators, that is the ones which we discussed: set W, set precision and set fill. Okay, using some example program here. Hash include string include h hash include igo manip. Okay, next into main into main and I want to use clear screen. Okay, now simply I am going to use these 3 manipulators. So see out, same examples try to take because you can realize. Okay, set W10 and print number 12 and some character. Externally we are printing here with star. And see out, set precision by specifying 2. Okay, and the number is 1 2 3 4 dot 5 6 7 6 7 8. Okay, and L. Here also before printing this new line, better to use NL. Now fill. See out. Obviously it comes with set W. That's why first one is set W. This width. Next set fill star character. So we used to use single quotes. Okay, and then number 5250, right? Next, let's see H returns in, right? Now save the file. Okay, um, this is manip all, because here we are using three manipulators, right? So manipul. Now run the compile the program. 0 errors. Run the program. See, in first statement we said the width as 10, so 10 characters. Okay, first we print star and 10 characters and print 12 and followed by star. Okay, so if you observe in between star and 1, you may have 8 characters with. Okay, in order to check, see next output, dot is one space in previous output, dot 23 e plus 03, and also space before 1. So how many spaces? 1 2 3 4 5 6 7 8 spaces from point to space in the next line. So that is in first output we are after star we are getting 8 spaces and 12, because before printing 12 we said the field width as 10, so we are getting 8 spaces before that 12. Okay, and next one is simply set precision 2. That's why here though the value is 1234.5678, here as that number is too long, here it is getting 1.23 e plus 03. Okay, and in the next output is we are setting width as well as we are filling with star and printing 5250. So first the width is 10, and value is 5250 and filled with remaining. So that's why 6 stars 5250, that is total 10 characters width. Okay, this is using manipulators. Okay, so till now what we discussed how we can change the base of an integer, and after that we have observed some manipulators, that is set w, set precision, and set fill. Right, now going to observe this set ios flags. Set ios flags. So here this sets the specified format flags. So whatever the flags we specify here, those will be affected on the output. So this set iOS flags sets the specified format flag, and the flags set by set iOS flags remain effective until they are reset or unset. Okay, until we reset or unset, these flags are these modifications affect on the output. And a format flag can be reset any number of times in a program, and we can apply more than one form at controls jointly on an output value. We can that is join, or we can combine any number of these flags format flags on a single output. Okay, and it sets the specified flags and leaves others unchanged. It sets only the specified flags, that is the flags which we specified using this set iOS flags. Okay, they will be set, and all the other flags will be unchanged. And this is the syntax for that: set iOS flags followed by F. This is the format flag we need to specify, okay, based on our requirement. So this is the syntax: set iOS flags, open parenthesis, F, and close. Okay, so here we will discuss some set iOS flags. So the possible flags are here. iOS scope resolution after operator left. That means here the output will be left justified. The flag is iOS scope resolution operator right. Okay, then the output will be right justified. And if you want to padding after sign or base indicator, then you need to use this flag iOS scope resolution internal. And if you want to print a number in scientific notation, then you need to use iOS scope resolution operator scientific. If you print a number in fixed point notation, then you need to use fixed. Okay, and here if you want to show the base for a particular output, then use this show base. Use base indicator on output. Show base. If you want to print position, okay, then positive. Show positive. So here print plus before positive numbers. Okay, and show point. Show trailing decimal points and zeros. Normally, when we are printing the floating point number uh, based on the value, it simply skips the trailing zeros, right, by default. So if you want to show them, then you need to use show point. Show base, show positive, show point. Okay, these are some other flags along with left, right, internal, scientific and fixed, and even we are having some other flags. So uppercase. Okay, so what we do, it use uppercase letters for hexadecimal output. So if you remember the previous example, that is in which we changed the bases. Okay, in that for hexadecimal we got a small e. So if you want uppercase letter, then you need to use this flag iOS scope resolution uppercase. And in order to skip white spaces, then you can use skippers. Okay, and in order to flash all streams after insertion, okay, you can use an it buff, uninitialized buff. Okay, and in order to flash all the std out and std error messages after insertion, then you can use iOS scope resolution operator stdio. Okay, these are some format flags which we can use for the set iOS flags as argument. iOS left, iOS right, iOS internal, iOS scientific, iOS fixed, iOS show base, iOS show position, positive, iOS show point, iOS uppercase, skippers, unit unit buff, uninitialized buffer, and stdio. Okay, now we'll see one example program using these set iOS flags. Okay, so this is example program. You need to use manip here. Okay, so all these are the formats to print a single value, that is 275.5. This is the value or the output which I want to display on the screen. But before printing this, I want to provide some formats. Over this number. So for that, here I am using this set iOS flags. Okay. So first is cout set iOS flags, iOS show point. Show points. That is, here it shows the trailing zeros. Though here we are not having any zeros, it will print that trailing zeros also. Okay, and show positive. So plus, and set precision. So though the input is only with one decimal point. Here we are, as we are setting 3, here we are getting 500, and fixed representation, fixed notation, and internal. Okay, these are the effects which we want to apply on a single output, Okay, let me execute this. Here what I am doing is I am using save as manip uh, iOS flags dot cpp. Okay, and here I want to change this instead of again and again writing all these things. Okay, so see out, set iOS flags, set iOS flags, iOS show point. Okay, show positive and all those things. Okay, in next statement I am going to print all the formats in a single output statement without having um, each and every one for each and every. So set iOS flags, iOS position positive. I am always getting POS as position only. Normally we use that POS for position. No? That's why I'm getting POS positive, not position. That is a positive. Okay, and set precision. So here I am using 3 as we discussed in previous one. Okay, the number is different now. That's fine. And set iOS. Here I am going to combine more than one flag formats in a single statement. Set iOS flags, iOS fixed. Okay, and for the same I want to write in a same statement. I set iOS flags. Okay, iOS scope resolution internal. Right, these two I am combining these two effects in a single statement, and after that I want to print number 275.5, because here I want to print floating point number 275.5. Okay, remaining is same. See how many flags we used. First one is show point, that is it shows the trailing zeros. Show positive, so if that is a positive number we will get a plus sign, and we are setting the precision, and we are printing that in fixed point representation, and we are using this padding at trailing zeros. Okay, so now save the file. Save the file, compile the program, address, uh, sorry, set iOS flags, so save the modifications, compile the program, run the program. See, though the output, the integer is, the value is 275.5. Here we are getting 500, that is with 3 precision and trailing zeros, and we can able to see the plus symbol. Okay, and that is in fixed representation. Okay, so like that. By default, the output of a floating point number depends upon the value of the floating point. But here we can change the format of the floating point number as our requirement. That for that we need to use this set type as flags. Clear? So here is one more example. You just see this. Okay. Manipulators manip and set diverse flags, show point and set W5, and here it is printing n, that is here I am going to print this n inverse of n and sum of terms as a column values. That's why here I am setting this width. Okay, so if you observe like this, you will get on the output n 15 by setting the width of for this inverse of n. Okay, so here you will get this by after some spaces like sum of terms. So in order to get these three strings as column headings, here I use this setable, and all are in single statement only. Okay, single statement only. Next, so for that here I am initially taking term and sum equals to 0 and using this for loop. For n equal to 1, that is for the 5 times, I am going to find the term and sum. Term and sum. Okay, and I want to print this n, term, n as the value of n, and this term as the value of inverse of n, and sum as value of sum of term. Okay, so these three variables and term sum will be displayed as the values of column headings. So here like this, 1 value, 2 here like this, from 1 to 5 for loop. Okay, so that's it. And say out set W5, because here we set the width for these three headings, right? So for that, in order to print these three variables, even we need to set the width. So in order to print n, we are setting width 5. Okay, and after we are printing term by providing some effects using these manipulators, that's we are setting the width of that is 14. Okay, and precision 4, and we are setting scientific notation. So the term, whatever the value in this first case 1.0 by 1 means 1.0 only, but that is represented like this 1.0000 e plus 000, because here we are trying to print that in scientific notation, not fixed scientific notation, and we set the precision 4. Okay, that's why here we are getting 1.0000. Clear? Okay, and before printing this sum which we calculated, we are providing some effects on this sum. Again set W13 and again scientific notation. So here sum, what may be the value of sum for the first iteration? 0 plus 1.0, that is equivalent to 1.0 only. So here you are getting the same with 4 precisions. Okay, so like that, for the 5 iterations we will get the values of n, term and sum. Okay, if you want to want one more example program for this IVA manipulators, okay, that is specifically here set IVA as flags. Okay, you can execute this program. Okay, I am not executing and I am not showing, right? So till now what we discussed about the manipulators. Even using these manipulators we can manipulate the output or input operations. Okay, so in that we discussed how we can change the basis of an integer. Okay, hex, decimal, oct. Okay, like that. And after that, what is the default format of a floating point number, on which it depends. Of course it depends upon the value of a floating point, right? And after that we discuss some manipulators like set w, set fill, set precision. Okay, and after that we discuss the set IOS flags. What are the different flags we can use as set IOS flags? We discussed everyone, and we have seen one example program, and here there is another example program for you. Okay, this is all about today's lecture. And even uh, the user, that is the one, we can also define our own manipulators. That is, there is a chance of writing defining user defined manipulators. Okay, we will discuss in next class. User defined manipulators, the user can also define their own manipulators. Thank you.